Let's work on understanding the concept of density, even though this is a topic which is mostly discussed in when we are studying about the physical sciences. Since there is a lot of comparison of numbers, so it's worthwhile discussing this concept here as well. Okay, so take a look at these two figures what we have here. The object number one is a soccer ball and object number two is a metal ball made out of iron. Okay, the similar thing between these two objects is that they both have identical radius or the diameter. They both have 22 centimeter diameter, all right? So because they both are spherical and they have identical diameter, one metric of measurement, which is the volume, will be identical in both of these objects, right? And that is 5572 centimeter cube, right? But when you compare the weight of these two objects, you will say that the soccer ball, of course, being a lightweight and being hollow inside, it's only 425 gram versus the metal ball, which has a weight of 43.8 kilogram. See, the huge difference between these two objects you find is one is made out of some rubber material and it's lightweight, and of course, the other one is filled with material and it's not hollow inside. And that is exactly the concept of density, in which it is measured as how tightly or how dense an object or matter is filled inside a unit of volume. So, in other words, it is the ratio of mass to the volume. This is a very standard way of measuring density of any object that we have learned so far as well, right? So if you apply this fundamental on the soccer ball, you will say that the density of soccer ball is, of course, the mass is 425 gram divided by the volume, which is 5572, and that comes out to be 0.076 gram per centimeter cube, right? And when you apply the same formula and find the ratio of mass to the volume, you will say that keeping the same unit of measures, which is gram per centimeter cube, you will find that this is equal to 7.8 gram per centimeter cube. So the density of metal ball is nothing but 100 times bigger than the density of this soccer ball, approximately, right? Which is quite a substantial difference, and that is exactly the concept of density brings to us, that it is a measure of how tightly or how densely something which is an object is filled inside a given unit of a volume, and this is exactly how we measure it. Okay, now let's take a look at a different situation. In this, what we are doing is that we are comparing the population of two cities, the New York City, where we have some 8 million people living, compared to the Union City, where we have about 66,000 people. And when you look at statistics like this, with only the number of people in your study, then you will definitely say that, yes, New York City is more populated than Union City. And indeed it is. But when you introduce one more variable into this dynamics, which is the area in square miles of that city, then you will say that with that reference, we can define another term, what is known as the population density. That means how many people are living per square mile in a city. Okay. And this is another definition of density that you're defining is number of people living in a city to the total area of that city, right? So this is known as population density, and that is exactly what we have measured here. Now, when you compare the population density of these two cities, you will clearly see that it is the Union City which is more dense compared to the New York City. And that precisely what density explains to us, that it is a measure of how tightly or how dense the amount of any substance is packed inside a certain unit of space, right? In the case number 2, if you look at this one, in the case number 2, you have the number of people in a certain area of a city, right? In the case number 1, you had the mass inside a certain unit of volume, right? So this leads us to another universal definition of density that could be described something like this. That density is the amount or the number of a given substance divided by the geometric measure of space. When we had that amount as mass, just like what you had in case number 1, and divided that by the volume, which is a geometric measure of space, what you had obtained was density as in the case number 1. But instead, when you use the number of people as the number of any given substance and divide that with the area, which is the geometric measure of space in this specific example, then you will come across the definition what is known as the population density. Okay. Now let's take a look at one example to better understand this concept, that what is considered as density and what is not. In this example, what you see is that 5 different measures, and we have to find that which ones of these are considered as density and which ones are not. So when you look at number 1, it is kilogram per meter cube. This is what we have learned exactly here, that it is a ratio of mass to the volume. So that definitely is a measure of density. Let's skip number 2 for a minute. Go to number 3. It is people per mile square, which is the amount or number of a given substance to the geometric measure of space, which is area in this case. So this is also a measure of density. And likewise, in case number 4, it is gram per meter, which is the amount of a given substance to the geometric measure of space, which is just meter in this case. So this is also a measure of density. But we will say that the number 2 is not a measure of density because it is miles per hour, and hour is not a geometric measure of space. So this is not a measure of density, right? And likewise, in the number 5, we have this minute, and minute is not a measure of mass. So this is also not a measure of density. The general definition or general concept of the definition of density, with that we will say that this is our key point, that how do you define density and how you can apply in different contexts, as long as you stick to the ratio of 2 items, which is the amount or the number of given substance to the geometric measure of space. Okay, so that is about density.